Let us discuss a question on torsion. So here, strength of materials, basically it's from torsion. So you have a composite shaft arranged in series. I should say actually arranged in parallel, though from the figure it looks in series. But if you consider the angular deflection or the twist, they are in parallel. Okay, so that we'll find out. But you have a torque applied 680 Newton meter, and then because of this you have a resistance which is set up in opposite directions, TA and TC at this fixed end. So such that now this TA are the reactions, internal reactions. In fact, not the internal reaction. I should say the reactions at A and C is equal to the net torque, which is 680 Newton meter. Okay, so now we need to find out the magnitude of the torque reaction at A. Now this is single equation where you have two unknowns. So I mean you cannot find out by this single equation. So now we need to know the information on the deflection. So on the deflections, what you should do is, well, if you consider this shaft, uh, okay, you have at here you have a fixed joint. So the angle of twist will be same here, whether you come from this shaft or this shaft. The angle of twist has to be same, or the theta BA, that is the deflection of B relative to that is the deflection of B relative to A. That means the twist of B twist of shaft 1, that has to be equal to the twist of shaft 2, which is twist B relative to C. Now twist at C and A is 0, so it basically means the twist of this shaft is equal to the twist of this shaft. Now how do you get the twist of each shaft? Now we use the torsion equation. Now T by J is equal to G theta by L. This is for a shaft where you apply torque, a constant torque throughout. Okay, you have a torque here, you have opposite torque here, so at any section the torque is T. So same thing, like each of the left shaft and the right shaft exhibits something like this. So we can use this equation. So TL by Gj is equal to theta. So let's use now on the left side, anywhere if you take a section and balance, right? Now let's just take a shaft like this. Okay, so you have TA here and you have TC here and you have external torque here. So if you take anywhere section on the left side, the torque, and balance the left side in equilibrium, so anywhere the internal torque is TA, and you take right side and take from right section, balance it, the internal torque will be TC. So that is good actually, so we can directly use. So for left shaft, TA L is same, by G material is same, so G is same. J is different because J depends, the polar moment of inertia depends on the cross section. On the right side you have TC. Okay, L is same, G, J, B. Let's say the shaft A is here. This is shaft A, this is shaft B. I'm just calling like that. We need to find out T and TC. Let's not lose in that. So this will get T by JA, because L and J gets cancelled. TC by JB. Now what is JA? J for a shaft polar moment of inertia is defined as pi d power 4. It's the area polar moment of inertia. Okay, so it's pi d power 4 by 32. Now this is again how is it defined? You take you find out moment of inertia along the cross sectional axis. Along this axis the moment of inertia, this axis the moment of inertia, and you add it. So it's normal along the normal axis. Okay, so you add it, you get pi d power. So along this, for a circular cross section, along this the I-axis is pi d power 4 by 64, and along IYY is also pi d power 4 by 64, and then you add it, you get the polar moment of inertia along the perpendicular axis, which is pi d power 32. Now for JB, the shaft B, it's pi d power 4 by 32. Now JA, where the diameter is twice, on the left side the diameter is twice, so by 32, so you get pi d power 4 by 2. Now you substitute it here, you get TA by JA, which is pi d power 4 by 2, and then you get TC by JB, which is pi d power 4 by 32. So it is TA is equal to 16 TC. This is important. So we got a relation by using this twist equation, deflection equation. Many people say it's compatibility equation. We get TA plus TC is 16. So now we use in the above equation, we get 16 17 TC. So we use in that 680 equation is 680. So TC is 40 Newton meter. Now we substitute TA, so 40 into 16 we get 640 Newton meter. So these are the torque in values. So let's see what is asked. The magnitude of the torque reaction support A. So it is 40. It is 40. So at A is asked, so it's 640. Sorry, at right side is 40. At left side is, so answer is 640. So always this when you have this torsion related problems, first equation is balance the torque as we did, TA plus TC 680, and the second is utilize the deflection equation, angular twist equation. Thank you.